Okay, we're going to look at some different algorithms for addition and subtraction. First, I'm going to look at a strange problem here because I want to review closure again. So this is to review closure. Remember, with closure, we need a set and an operation. This operation is supposed to be a little target. I don't know why the symbol didn't show up. So we'll make it a little target. So the way this is working is you read here, A target C gives C. B target B gives C. C target A gives C. So the closure question is actually straightforward. Every time we take two of these elements and we use the operator on them, all of these results are still in the set, so yes. S is closed with respect to the operator target. Now, is there an identity on S? This would mean for every two elements, like A target B should equal B, and B target A should also equal B. That's like saying 1 times 3 is 3 is equal to 3 times 1. That's our identity. Well, let's look. A times A is A times A target A is A target A is A target B is B target A is B, A target C gives me C target A, C target A also gives me C. Just I got confused with reading that thing. Anyway, it looks like A is the identity because look, A target B is B, B target A is also B. A target C is C, C target A is also C. So it's working as the identity as well. Okay, we did some of these in class. So I'll run through the standard algorithm. You listen to my language and laugh at the bad place value. 6 plus 7 is 13. I do the 3, I carry the 1. 1 plus 8 is 9, plus 2 is 11. I do 1, I carry the 1. And I add those and I get 313. So of course the place value language was terrible. These are not really ones. In fact, that's a 10. This isn't a 1, it's really 100. And I wasn't adding 1 plus 8 plus 2, I was adding 10 plus 80 is 90 plus 20 is 110. So there's the 10, and then that was the 100. I'm going to go through this fast because this is what you did in the lab, where you put two groups together. You know, here's your 187, here's your 127, and then you started to regroup and exchange. And so you're doing diagrams, and if you do cutouts, you can do manipulatives. Okay, I'm going to show you another way to do it, 186 plus 127. Because we were taught with our standard algorithm to start from the right, but you don't have to. You can start from the left. And now listen to my place value language. 100 plus 100 is 200. 80 plus 20, that's 100. 6 plus 7 is 13. And then I add these, and I've got it. So the place value is really strong here. And to be honest, I kind of like it better than the standard algorithm. We learned lattice algorithm in the lab or after class. I can't remember now. I guess it was after class. Let's review it. Let's add 5, 6, 8, 7. And let's add 6, 9, 7, 4. So we build our lattice, our array of these things. And now we fill it in. 7 plus 4, 11, 15, 15, 11. And now we look at the diagonals. So there's 1 in the ones. Here's the tens. That's a 6. Here's the hundreds, another 6, the thousands, a 2, and then the 10,000s with a 1. So our answer is 12,661. Okay. Subtraction. Notice they built 243, and then you have to take that away. Well, I can take away the 1, but I can't take away the 60 because I only have 4 of the 10s. So you know you're going to have to exchange this for 10 more of those, and then you can take away the 6. Okay, I showed this. So let's do 2,463. Let's subtract 1,582. And I'm going left to right. I'm going to do 2,000 subtract 1,000 is 1,000. Now, we were taught you can't take 5 from 4. And yet later on, we're going to learn about negatives, you know, like 4th or 5th grade. And I know this is negative 100. So 400 subtract 500 is negative 100. 60 subtract 80 is negative 20. 3 subtract 2 is 1. 1,000 minus 100 is 900. Subtract 20 is 880. And I add the 1, 881. 1,881. Stop that. I already took that 1 away. It's 881. Sorry about that. Let's do another one. Let me think of some good numbers to build. Let me change color on you. Let's do, since I had so much fun with the thousands, let's do that again. $3,000 subtract 1,000, 2,000. 300 subtract 700, negative 400. 80 subtract 20, that's positive 20. 2 subtract 5, negative 3. Well, if I combine these, I'm at 1,600. I add 20. Then I subtract 3, 1,617. And I prefer this algorithm over the standard algorithm because I really like the place value. It shows everything. And what it means is we don't tell everyone that you can't take 5 from 3 because you can 5 from 2. You can subtract 5 from 2 because you get negative 3. And just to watch this one, some kids learn this mentally. I challenge you to figure out what's going on here. rather than use any algorithm here, and this really is a mental strategy. At least that's how I've seen it used. They're adding 7 here because we're getting to a nice number, a decade number. Okay. They're going to add 30 to each of these because we get a really, really nice decade number there that we can subtract from the 292. So mentally, this is kind of cool that kids can hold this in their head. I would do, well, I get 100, I get -10, I get 2, that's 92. So that's addition and subtraction.